Carsten Ziegeler, working for Adobe. I'm also a member of the Apache Software Foundation and the current VP of Apache Felix and Apache Sling, both projects doing different OSGi stuff, and as Richard said, I'm involved in OSGi and the expert groups. Next to me is Bosschaert. He's working from Ireland for Adobe as well. He's the co-chair for the Enterprise Expert Group, big fan of open source, enthusiast for cloud stuff and embedded things, and he likes doing IoT stuff. Yes. And we are talking about new stuff in R7, and I guess David will start.
So this session will have a lot of topics, and we'd like to kind of give you an elevator pitch of pretty much all of the new, or most of the new technologies that you're going to get in OSGi R7. Actually, just one of the things to start with is that there is a draft, an R7 draft released yesterday by the OSGi Alliance. That draft is very, very, very close to what the actual specs will be. There's one spec that we still need to do some work on, but other than that, I think pretty much everything is in spec form available today. And many of the technologies are also available to play with today because they're implemented in open source. So, the first kind of technologies, group of technologies that I'd like to kind of look at is what I would call OSGi basics. And I'm going to start with some bundle annotations that are new in R7. So we actually already had some bundle annotations that allow you to kind of specify the version of a package and whether it was a provider type or a consumer type. That was already available in previous versions of OSGi. And there's now a new annotation that basically allows you to specify this package is actually exported. Some tooling today actually interprets the versioning annotation as being exported as well. Now there's a new annotation that makes that explicit, a little bit more correct. So that's there as well. Some other annotations are actually a more interesting, I find personally, and they are around capabilities and requirements. So OSGi has this great capabilities and requirements model, which is basically allows the resolver to collect together all the bits and pieces you need to run your application. And much of the tooling that exists today already automatically generates capabilities and requirements in your code based on what code you've written. But in some cases you need to add this by yourself. And previously you had to kind of write your POM or whatever build tool you were using to add these headers in manually, and that wasn't really that nice. So now you can just, for example, if you need a HP whiteboard implementation, you know that in your code you are depending on this, so you want to make sure that that is installed at runtime. You can put an add requirement in your code, like there, to say, okay, I want OSGi HP implementation. That's the capability that the HP whiteboard provides in version 1.1, for example, and that will result in a required capability manifest header. There's also an add header, which is more general. So basically that allows you to specify any kind of OSGi header in your source code, which means that none of the headers have to be specified in the build system. So if you want to specify a bundle category, or you want to specify what the activator is or something like that, you can use the general add header annotation for that.
The version, is it OSGi range, or is it?
Capabilities and requirements don't generally use ranges, but this is no, it's one version. It's one version. And what you do with the capability is that the capability provides all the versions that it's compatible with. So as a consumer with capabilities and requirements, you can just specify one version. Okay, the next basic technology that is in there is an entirely new spec called the object converter. This was based on some work that Peter Green started in the B&D tool chain, and Peter basically wanted to convert anything to everything. He wrote that as an implementation, and we kind of picked it up in the Alliance as a new specification, and it's basically ready now and available also in Apache Felix project. So what it allows you to do is it allows you to do simple conversions, like for example between collections and arrays, or between scalars and collections, but it also allows you to do some more interesting conversions between, for example, interfaces and DTOs. If you have a DTO, you want to convert to an interface because they kind of look the same, you want to convert to each other, or between maps and annotations or something like that. So because this converter, the idea is that people use it everywhere, we wanted as little implementation freedom as possible, so the spec tries to kind of nail that down completely for you, but we also acknowledge that it may not be exactly what everybody needs. So while it has completely predictable behavior, it can also be customized. You can create your own custom converters to tweak it a little bit, to make it useful for your own purposes. So let's have a look at how this works. For example, if you want to obtain the standard converter, you just call a static method on converters. That also actually shows that it's not an OSGi service by itself. You can obtain it using a static API, which means you can also use it outside of an OSGi framework. But what you typically do is you obtain it like this, you tweak it, and then you register it in the service registry so that all of the components in your application use the same customized converter. So yeah, if you want to convert something simple like a string to an int, not very interesting to be honest, but it has an API, convert 123 to an int, that works. And you can use the exact same API to convert a string to a UUID, which is a tiny bit more interesting. But you can then use the exact same converter API to convert a list of strings to an array of shorts, which is already a couple of lines of code if you wanted to do this by hand. But now it gets really interesting is when you want to convert map type data from one type to another. And a typical use case is, let's say you have a map of configuration values and you want to use these at runtime. So your map might contain some strings, but really at runtime you want to consume these things as typed objects. And you might have defaults that are not specified in your map. And this is really where the converter can become very helpful. As you can see in this example, where the configuration contains a refresh string of 750 and some other value. Now, the other value I'm not interested in at all, but it just happens to be my configuration. Then at runtime, I really want to obtain the refresh rate as an integer. So I specify an annotation where I specify refresh as an int with some defaults. Now, annotations are really useful here because they have a limited typeset, so that kind of maps to typical configuration data. They don't allow you to return anything. They only have a limited amount of things you can return. And it allows you to specify defaults like this. So then I use my converter to convert my map of data to my annotation. And there you go, I can now use it at runtime. If it's specified, it works, it automatically converts it to the right type. If it's not specified, it takes the default. And then finally, if you want to customize your converter, here's a little bit of code that shows you how to do this. I won't go into too much because I guess we're getting a little bit short on time. But just to show that, let's say there's a conversion that's not supported out of the box. Like for example, a conversion from string array to string out of the box that only takes the first element because you're converting a multi-type element to a scalar. Let's say you want to do something special there. You can create your own method, reference your own method with the converter builder, create a new converter that uses that, and your custom conversion is registered. And what you end up with is a converter again, which is immutable and can be shared across your application. The nice thing is that your customized converter can also be yet customized again. So that's kind of the conclusion of the basics that we're talking about here. There's also additions to promises, and there's a new push stream spec that we're not covering right now, but there's talks later in the week about that by Tim Ward, where these are covered.
Right, this brings us to the second topic, which is service development. Before I go into that, does everyone know OSGi? Or if not, raise your hand. I mean, just the basics, right?
To some degree.
To some degree, that's perfect. Right, okay, cool. So, in the R7 release, we are improving the Declarative Service specification, which is part of R7, and that's basically the way you should develop your OSGi components. And if you're using Declarative Services, it's pretty easy. You just write your code stick some annotations here and there, and that's all you have to do. But before it gets easy, it gets a little bit more complicated, just to show you how DS actually works. When you deploy a bundle which has your components inside that bundle into the framework, the DS implementation looks for an XML descriptor. Yes, it's XML, it's nice and clean. And it looks into that XML descriptor which describes which services and components this bundle actually contains, uses that to then register the services on behalf of that bundle into the service registry. So you don't have to take care of these things, but you have to somehow provide this XML descriptor. So a slide before I said it's really easy. If you're doing DS, writing XML doesn't sound easy. And that's why we have a lot of annotations, and these annotations are used at build time to create that XML for you, so you don't have to worry about this. But it's good to know that there is an XML file. In case something goes wrong, then look if it's really creating what you were intending to have within your bundle. So if you want to develop a component, you just write your class, stick the component annotation on it, and that's all you have to do. You build your bundle, deploy it, DS will pick it up and register it as a component. More interesting is a component has a life cycle. It gets activated when your bundle gets deployed and started. It gets deactivated when your bundle gets stopped. And you can implement methods that are invoked exactly for activating that thing and deactivating that thing. Just stick the activate and deactivate annotation on that methods. That's all you have to do. And then the DS implementation at runtime creates the instance, calls the activate method. If your bundle will be uninstalled, it calls the deactivate method. Nice and easy. More interesting actually is if you want to provide a service that gets registered into the service registry. You still use the component annotation, but then specify the service with the service attribute on that annotation. So in my case, this component is registered as my component. That's the type of the interface. And what I presented so far is already available in R6, the current available implementation. And here's some new stuff from R7 actually. If you're familiar with the old things that you wanted to provide service properties with, and your service gets registered with these service properties in this registry, then you have to use this strange concatenation of strings, which is strikes through at the top. With R7 we provide new annotations. It makes it much easier and nicer and cleaner and type safe even to do so. So we have a service description annotation, a service ranking annotation, and more interesting is you can define your own annotations. Like in this case, there's a tag annotation where you just provide an array of values, and this will create a service registration property of some name tag in that case, which has two values, foo and bar. That's way nicer than doing all these things up there, which look really weird.
Question?
Yeah.
Can you also combine it to have one annotation that is providing a service property, but also maybe provides a requirement in the bundle that you need some kind of technology?
That's a good question. I guess you could annotate that annotation with the requirement annotation. That might work.
But I think the tooling will pick it up. It's the tooling that needs to read that stuff, and I think it will work.
So you do that, yeah. That's an interesting point. We have to check if that works. Yeah.
If your component doesn't implement my component, I just put a component, so it's an immediate component. It's not providing a service, but I put a bunch of annotations. Those annotations are service properties. Are they going to be just component annotations? They're not going to be service properties?
Right. So if this thing is not registered in the service registry, basically more or less whatever you specify as properties has no meaning at all. It just gets more or less ignored. Okay, so this gives you a service into the registry, and usually if you're developing a component, you want to use other services. So you have references to other services. And the most simple way of doing that is simply having a field in your instance, sticking the reference annotation on that field. The type of the field is the interface of the service you're interested in. And once DS activates your component, it will set that field with that service from service registry, call your activate method, and then your service is up and running. This also handles all the dynamics. So if this resource resolver factory is going away, this component will be unregistered as well, or the service will be unregistered as well. If the resource resolver comes back, this will be registered again. So you don't have to deal with the dynamics in the service registry. But that's just the simplest case, and the reference annotation has a lot of options you could use throughout your code, depending on what you want. In some cases, it might be interesting to get all instances of a particular service. For example, there might be a set of filters you're interested in, or a set of loggers. And you can just do that again with the reference annotation on the field. In this case, the field just has a type of list of filters. And then DS will activate your component. And in this case, this thing is actually dynamic. And DS will set that field to a collection of filters and put in the current available filters from the service registry into that collection. If there's a change for the filter service in the registry, it will set a new collection into that field with a new set of filters available. So that field gets updated at runtime. So you have to check in your code that you first copy the current thing into a local variable, iterate over the filters, and you're fine with concurrency in that case. So these are references to other services. Again, nice and easy with annotations. The other interesting thing is handling configurations. And we have, as a specification, configuration admin, which manages all the configurations. You can create them, delete them, update them, and so on. And usually a configuration has a PID, a persistent identifier, and a set of properties, basically a map. So now if you want to have a configuration for your component, you need to somehow define what are the possibilities to configure this component. So what are my properties? And in this case, we just want to have three different properties with some types and default values. And you define that by defining a so-called configuration property type, which is an annotation. And this ties in with what David showed earlier on the converter example. You can just define this annotation, specify the properties, and default values for the properties. Again, that's the reason why we have chosen an annotation here, as you can directly specify default values. And then this configuration will have these three topics, these three properties, enabled, topic, and username with those default values. Yes?
One more question here. This interface is very nice to define and also very nice to get properties from outside, but when you have a test that is not running OSGi, is there a good facility now to create such a...
You can just mock them.
Or you can use a converter to create one.
That's the other option.
Yeah, the converter can create one. You just create a map and you define the annotation, and then you convert the map to the annotation, and then you got one.
That sounds good.
Yeah. Or as I said, I mean, if you're using some mocking library, you can mock annotations as well. So it's depending on your style. Right.
There's also a piece of Google code that can do this by using context.
Yeah. Right, so you have described our configuration, and if you just want to use it, actual configuration provided by configuration admin within your component, and you can use a new feature of R7, which is basically you just create a field with a type of that annotation from the previous slide, stick the activate annotation on that field, and again, once the component gets activated, DS will put the current configuration into that field, and that's all you have to do. For those who know R6, you have to write an activator and put that field yourself into, put that configuration yourself into the field, so this now gets cleaner with just sticking the annotation there. And the other new thing in R7 is constructor injection. So finally, we have that. You can just stick an activate annotation on a constructor, and that constructor then can take all the things that you could usually put or get through an activate method and references to other services. And you can do whatever you want there, get references to these services, get your configuration, and directly handle that in your activate and your constructor.
What's the use case for this?
What's the use case? A lot of people were asking, we want constructor injection.
I guess it's people who like final kind of immutable.
Yeah.
Right?
Yes. And the other thing is that with this you ensure that you already have stuff before your activate method is called, or before a bind method for references is called, because it's in your constructor already. So it's a nicer way of handling ordering of things. And as I said, I mean, a lot of people were asking for that, and that's why we did it.
Static, right? Like the reference.
Yes.
Everything is going to be static.
The references have to be static, correct. Yeah. That was the question?
Is it possible to, on a field, to annotate with the modifier? The properties change? I think there's
yes.
annotation for a method, but also on a field.
No, that's not possible. That's not possible. So if I'm going back to, so for references, of course, that works. But if you, for example, using this one here, you can't stick in a modified annotation on that field as well. This is, I think we don't allow that. So if you want to handle modified, you still have to implement the modified method and stick the modified annotation on that method, I believe. But I might be wrong. The good thing is, there's a talk about DS tomorrow morning by BJ, who's a spec lead on DS, and maybe that's a good chance to ask him, because he will definitely know.
I guess modified and activate on an constructor would not make sense, because we would not want to have it both ways.
Yeah. I mean, for configuration, it might make sense, right? It might change at runtime, and you can handle that later on.
You wouldn't put modified, you would put volatile.
Yes, exactly. Yeah.
If for the Java numeric medallion, you have to guarantee this change out the context.
But as I said, I think we don't support modified on the field. Right. So the other thing is that we already defined this component property type, which is annotation, but it's not really meaningful to a user who wants to configure your component. You just see some properties and default values, and you maybe want to provide some more information, and you can use a meta type specification to provide meta type information about your configuration. Again, a set of annotations which you can stick on this component property type, this myconfig, and then you can define labels and descriptions for the whole configuration and for each property, so it gives more information to the user. I guess you wouldn't use such dumb comments that we have chosen on the slide, but give more feedback to the user. And then if you're doing that and want to tie this meta type configuration to your component, you have to use a designate annotation on your class to tie that together. It's just the mechanics you have to use. And the final thing is, we've seen a lot of properties here, how do they all fit together, and then what really ends up in the service registry. So we have the property attribute on the component annotation, we have these component property types, which are these annotations you define yourself, and you have a real configuration and configuration admin stored for your component, or it might not be there. And all these things are actually added in exactly that order, and that's the set with which your service is registered in the service registry. That's also the set which is put into your activate method or into your activate field, just to wrap that part up. This was really a very quick run through Declarative Services. As I said, tomorrow morning is a whole session about that. It takes care of all these dynamics and then makes it pretty easy to develop your component. Yes, please.
If you would have in configuration some field like a password that you don't want to publicize like that, can you somehow hide the information on the service registry?
The underscore.
Yes. Yeah. If your property starts with, or your property name starts with an underscore, then it's not put into the service registry.
To report in the real
yes.
Property.
So yeah, that's a good point. I mean, it's maybe a little bit too detailed, but for this session. So here you would use an underscore, but actually, if you're using such an annotation, an underscore is converted to a dot. So actually, your configuration property has a dot at the beginning. But I guess that's maybe too much. The good thing is we have this spec out there. It's pretty good written, and you can read about all these details there. Yeah, so this wraps up the service development part. Just use configuration admin, meta type, and especially declarative services to develop your stuff. And what else do we have?
Right, so I'm going to talk briefly about some new work in the context of web development. And there's one new spec there, and that's the JAX-RS support spec for OSGi. And JAX-RS was basically never really supported in OSGi, and it was kind of hard to make it work in OSGi. That's now kind of fixed. And it follows a similar model, like it follows the whiteboard model, the service-based model. So for those people who know the HTTP whiteboard spec, it's very similar to that. So how does this work? Basically what you do is you create your JAX-RS bean the normal JAX-RS way. So here's an example where you have a JAX-RS bean called test service. JAX-RS beans don't have to implement a particular interface, they can be anything you want, and you annotate them with a path annotation, which is a JAX-RS annotation, and for example, a HTTP method annotation like @get. Now, to make that JAX-RS bean an OSGi JAX-RS component, you have to register it in the service registry. So in this example, I'm using DS because we all like DS a lot, and it makes things nice and simple. So what I do here is I simply register that component in the service registry under its own class, like it doesn't really matter what service it is. And I annotate it with the JAX-RS resource property. So this is another example here where you can see the special annotation that is put on the component, and the actual result, like Carsten explained earlier, the actual result of that is the service property. If you didn't use DS, you don't have to use that annotation, you have to put the service property on there by hand, which is a lot more error prone and a lot more typing. Another thing that is kind of interesting to point out here is that we use this service scope prototype, and that is basically to give these services the same semantics as what you would have in a JAX-RS component in Java EE. In Java EE, every client of a JAX-RS component gets a new separate instance, and if you store any kind of state in that instance, that that state is limited to that same client. And to get that same behavior in OSGi, we can use the service scope prototype. If your JAX-RS bean does not have any state, then you don't have to specify that. But that's just if you want to have completely similar semantics, you put that on. And the nice thing is, like, it works fine with and great with other DS kind of functionality as well, right? So if you want a JAX-RS bean that is injected by DS by some kind of other service, then you can use @reference. You can have activation methods. That's all kind of that works nice. You can just combine these together. And it also supports JAX-RS applications, which are just a way to group a bunch of JAX-RS beans together. And it supports JAX-RS parameters, as you can see here. So you can specify a name parameter and then pick it up again here. That's just normal JAX-RS functionality, but that works as well.
One question. Can I also annotate interfaces with this resource annotation?
In here, right?
Let's just assume it's not a not a class, it's an interface.
I think in terms of JAX-RS, you have to provide an implementation, right? So yeah, if you have a default method.
I know that I can do it with plain JAX-RS directly. I have done this already, but obviously I don't know what the scope of research.
I have to admit that I don't really know, but there is a more detailed talk about JAX-RS, an entire talk about JAX-RS, I think tomorrow. So that will be a question for Dan.
But I guess in this case it's really not possible because that thing is registered in the service registry. Actually, so, and that has to be an implementation then.
Right, I think so.
But it's a good idea to ask.
It's a good question. It's a good question. Right, just to summarize the JAX-RS support, so we have like the normal HTTP verbs, application support. It supports JAX-RS extensions, so you can write your JAX-RS filters and interceptors, and it has some special annotations for DS. And then, so that in terms of web development for R7, so obviously we have the JAX-RS stuff, but we also made some updates to the HTTP whiteboard specification. It now supports multi-part file uploading, and it also supports something called a preprocessor, which is great for handling security, for example, if you are using HTTP whiteboard. I didn't really cover that because we had to kind of limit it somewhere. Okay, provisioning. Oh, Carsten.
Okay. Right. Another thing is that we never really had in our specifications a format how you could write down OSGi configurations. And if you're using different tools, for example, like the Apache Felix file install, you use some properties files, or there's a new way, a new file format actually. Other tools use other formats, and so we thought it might be a good time to just specify a format that everyone is hopefully happy with. And we actually decided to use JSON. Don't ask why we chose JSON. That's the way we did. And actually, so in this case, it's a simple JSON file defining three configurations. You use a PID, this persistent identifier, as a key, and then properties with the values as the properties of that thing, of the JSON object. And you could also use typing in there, so you could, I mean, JSON already provides or supports some types like strings or integers or floats. But for example, if you want to have a char, a configuration property of type char, you can use this :.char annotation and all these things. And there's a new, nicer way of dealing with factory configurations, so you can actually give them a name and then use that name to reference factory configurations. And that's actually a new feature of R7, because previously it was always a little bit difficult to deal with factory configurations. So we have this nice format, and we have a new specification configurator, which allows you to stick these JSON files into a bundle, deploy your bundle, and then the configurator will pick up the JSON files and apply the configurations into configuration admin. And it handles all the states. It deals with if two configurations provide, two bundles provide the same configuration, or configuration for the same PID, to be precise. It does a state handling, does a ranking. It's all very well defined, and you always end up in the same state regardless of the order and how you deployed your bundles. You could also stick binaries into the bundle and then reference a binary within your configuration. That's handled as well. So it's pretty nice stuff if you want to do that. And with that, we come to the last topic.
Final topic of this presentation, which I would call clusters, containers, cloud, action, or something like that. So as probably people in the room know, OSGi is already being used in the cloud for, successfully by many projects, and it's a great technology to run cloud-based systems. What we have added in R7 is a new spec that used to be called Cloud Ecosystems. Now it's called more generally Cluster Information, and it gives you information about OSGi frameworks and other entities that are running together in a distributed environment. So that could be cloud, it could be a bunch of Docker containers, it could also be IoT, because the problem space is actually more or less the same. It's just different types of frameworks, different types of hardware that run in some sort of a cluster. So cluster information gives you information what frameworks are running in the system. It gives you callbacks when new frameworks arrive. It also can tell you about, whether your database is running or where it is running, or anything else that is of kind of, any kind of other metadata about your cluster. So how does this work? Cluster information basically uses the OSGi service model to announce these things. So the services contain properties. The properties provide information about your cluster. The fact that the service is there means that an OSGi framework is somewhere. So if you're in a distributed environment where 5 OSGi frameworks are running, you have 5 services that represent these frameworks in your local service registry that you can find out about these frameworks. And you can read out information. You see in the next slide what kind of information it is. But you can also use these services to make changes to your deployment. OSGi is great for dynamically changing your deployment. You may want to reprovision your framework to do something else because you've got a new bunch of frameworks available. Maybe you want to spread the load out. Or maybe you have another task that needs to be done. You can kind of remotely install some bundles in these frameworks and change the behavior of what you're doing. So this all kind of works through a service called the Framework Node Status Service. That's just an ordinary OSGi service that provides you metadata about things like the Java version, the OSGi version it's running, the version of the OS, which might be useful to know in some cases. Very importantly, the IP address. If this framework runs a database for you, then the IP address might be something that you want to talk to, you want to connect to. It actually provides the information about the physical location, if you might have legal requirements to know that kind of information. And it also allows you to obtain some metrics of that, how the framework is doing, if it's overloaded or if it's like doing nothing, and you can obtain metrics from it. And you can add your own tag. So maybe you have a bunch of frameworks that run on specialized hardware that can do number crunching for you. You can add your own tags and say, oh, this is the number crunching framework, and then use that once you get the information injected into your system to give it tasks that are suitable for that kind of hardware. And then finally, you have this provisioning API that allows you to do bundle operations like starting and stopping bundles, installing and uninstalling bundles. Right. So that was really, really short in a nutshell. A bunch of new specs that are there. We didn't even cover all of them because there's also transaction control, which is an entirely new spec. We didn't talk about that. JPA updates and remote service intents. There are other talks this week that cover these as well. But if you want to have a look at them, go to this location or just go to the OSGi website and find the drafts link there in the specification draft link. And there you can see all this stuff in detail and find out about it. Questions?
Yes. How far is the implementation in the different OSGi frameworks along?
So the frameworks themselves didn't really have to change that much because the core framework is really, really, really stable. And in R7, there are some very small changes made to the framework. I know that Equinox has already implemented those. I'm not sure how far Felix is. I don't think Felix has implemented these. But all of the things that we talked about are actually not framework changes. They are separate service implementations that are all available today, like in various communities. So, for example, the cluster information I just mentioned is implemented in Concierge, in Eclipse Concierge. Configurator is in Apache Felix, Converter is in Apache Felix, JAX-RS is in Apache Arias. So all of that stuff is available in open source, and it actually runs on top of an R6 framework, as far as I know. Right?
Most of it. Yeah,
I think the core changes to the core framework are really just some tweaks to the DTOs, and I think that's more or less it.
Yeah, and I think most of the implementations are really up to date, so they implement nearly everything that we have presented.
Yeah.
I know for the ES, because I'm maintaining the implementation, the only thing which isn't implemented yet is the constructor injection, because we just added that last week.
And not done.
Not done, no.
Tomorrow.
I'm here, tomorrow.
Any other questions? Yes, Simon.
So last year we talked, Carsten talked about the possibility of updating configuration of the alpha components. much could be only done so far with, so the one who wants the service